Our solar system, a yellow star in the middle surrounded by 8 planets. Each one of these planets in a unique orbit. When each planet completes one orbit around the Sun, it is a year. The year is different from one planet to another. Our Earth year is 365 days. The smaller planet's orbit is like Mercury in just 88 days. Venus has an orbit completed in 225 Earth days. Mars' orbit needs 687 Earth days to be completed. Jupiter has a very big orbit. Its journey takes 12 Earth years. Saturn year equals about 29 Earth years. Each time we go far away from our Sun, the planet's orbit gets bigger. Like Uranus, which completes its orbit in 84 Earth years. Pluto's orbit needs 248 Earth years to be completed. It is the biggest orbit. This small planet is controversial between astronomers. Some of them refused to consider it a planet at all. The others insisted, as it is a dwarf planet. But there is a big gap between the orbit of Mars and Jupiter. A big orbit inside our solar system. The center of this orbit is the Sun, our Sun. In this orbit, there are a huge number of rocks and dwarf planets. There are hundreds of dwarf planets waiting to be discovered. There are some conditions to consider any object a planet. The most important is the orbit. It should be around the Sun or around a star. Any object's orbit around a planet considered to be a moon or natural satellite. The mass of the planet and its own gravity create the spherical shape. To consider any object in the universe as a planet should be spherical or close to that shape with its own gravity. These conditions were the reasons for the disagreements between the astronomers about Pluto. In the end, they agreed to consider Pluto a dwarf planet. The International Astronomical Union recognizes only 4 dwarf planets in the orbit between Jupiter and Mars. Ceres. The biggest dwarf planet in the Asteroid Belt, and the most spherical one in the Asteroid Belt. The only object in the Asteroid Belt big enough to be called a dwarf planet, with a diameter of 950 kilometers. A dwarf planet less than the third of our moon. The surface of Ceres cannot be visible even with the best space telescopes, except when it is very close to the Earth, once every 16 months. The most important point of Ceres is water. which has been discovered by the Herschel Space Telescope as a water vapor around it. For the astronomers, water vapor is a proof of life, a probability of existence of a living organism. Ceres' orbit is bigger than Mars. It takes 4.6 Earth years to complete its orbit. The gravity of Ceres is almost 3% of the gravity of Earth. It is the most water-rich body in our solar system after Earth. There is no atmosphere, but its gravity is enough to contain the ice water on it. Ceres' temperature ranges between -33 to -93 at the daytime, but the nighttime is very cold. It may reach to -145 degrees. Ceres' surface is a mixture of water ice and hydrated minerals, including carbonates and clay. The strong gravity of the giant Jupiter nearby Ceres was the reason to prevent the complete formation to be a planet. 4 billion years ago, Ceres settled in this location between Jupiter and Mars in this orbit with hundreds of other objects. Dawn, the NASA spacecraft, was the first to orbit Ceres. Provided us with a huge amount of information about that unique dwarf planet. We can see very clearly the surface terrain of Ceres, such as the biggest crater, which is about 2 miles deep. The camera of Dawn gave us a clear picture of the largest mountain on Ceres, which is about 4 miles high. A unique mountain, dark on one side and very bright from the other. Those pictures were taken from a distance of about 2,700 miles. But we are still hungry for knowledge, to know more about the geology of this planet that will need landing on this planet to discover more and more. Among this orbit, there is another small dwarf planet with diameter less than 600 kilometers. This small, tiny planet has a very short day. It is only 5 hours and 20 minutes. It required 3.6 Earth years to complete its orbit around the Sun. Vesta 4. Vesta is a rocket planet, almost 1/7 the size of our Moon. It is the source of many meteors that fall on our Earth. Vesta's shape is oblate spheroid, so the temperature on the surface ranges between -60 to -130. The spacecraft Dawn orbit Vesta about 1 year before leaving to Ceres and provides us with very important information. The south pole of Vesta, a very clear image taken by the camera of Dawn. Also, we had a very clear image of Rhea Silvia, the largest impact basin on the surface, and Venonea on the south pole of Vesta. Due to the impact which happened a long time ago, the surface terrain of Vesta is full with more craters like Helena crater. One of the distinctive terrains of Vesta's surface is the set of steep cliffs. The NASA astronomers called them Matronlia Roops. Davalia Fossa, a group of parallel grooves, looks like a river 20 kilometers. NASA's Dawn spacecraft did a wonderful job to discover this planet. Aricia Tholis, one of the discovered mountains. Snowman Group. A group of 3 adjacent craters in Vesta: Marcia, Calpurnia, and Minutia. Saturnalia Fossae. Also like Davalia Fossa on South Pole, there is the same terrain in the north. The North Pole of Vesta. 2 Pallas. The second dwarf planet was discovered after Ceres. The diameter of Pallas is about 515 kilometers. The orbit of Pallas equals the same orbit of Ceres, which is 4.6 Earth years. The day duration in Pallas is almost 8 hours. Pallas, composed mostly from silicate. Dawn spacecraft did not orbit Pallas due to its orbit inclination, which made the mission very hard compared with Dawn trajectory. AGIE. This small object was discovered by observation of the Very Big Telescope sphere between 2017 and 2018 as a spherical dwarf planet. Hygiea Dei is almost 14 Earth hours and completes its orbit around the Sun in about 5.5 Earth years. Planets are stable objects. A planet exploding in space is not normal at all under typical circumstances. To cause a planet to explode, a tremendous amount of energy would be needed, like a direct hit from a very large asteroid or the intense radiation from a nearby supernova. If that happened, it would likely disperse into smaller asteroids, dust, and debris. But it will be hard to see a dwarf planet, since the composition of the planet needs a gravity and stable orbit, which is hard to be created from explosion.